Enterprise software systems inevitably grow over time, and many start becoming increasingly difficult to manage. Quick fixes and suboptimal decisions accumulate, causing tasks that once took a day to stretch into several days, or even longer. Decision making slows down, and the back and forth between teams and stakeholders increases. Organizational misalignment grows and can be hard to detect on time. The organization believes that the solution is simply hiring more people, which adds new layers of management and more bureaucracy. Communication between teams breaks down, responsibilities become blurred and overlapped, which leads to duplicated efforts and silos. And the worst part is the resistance to change. Sounds chaotic, right? These are the signs of accidental complexity, the unnecessary complexity we introduce into our systems and organization. Hey everyone, welcome to Engineerize. I'm Osman, and here we explore everything from technical practices to leadership and organizational problems in software engineering. In this video, we'll explore what accidental complexity is, how it, especially organizational accidental complexity, can undermine enterprise software systems, and how certain disciplines and practices can help manage accidental complexity. There are two types of complexity in software systems. The first one is called essential complexity. It's simply the problem itself, meaning that the problem equals essential complexity. Let's say a delivery company needs to plan the shortest route for its couriers. In order to solve this problem, you have to use a shortest path algorithm. So the complexity in this example is the shortest path algorithm. Complexity comes with a problem. There is only one way to escape essential complexity, which is not solving the problem. On the other hand, there is accidental complexity, which doesn't come with the problem but the solution. Accidental complexity is the unnecessary and often avoidable complexity we introduce into the systems or organization through our choices. It's not related to the core problem we are trying to solve, it's the mess we create ourselves. Most of the time, the solution ends up being a mix of the essential complexity and accidental complexity we created. Accidental complexity is divided into two categories: technical and organizational. Technical accidental complexity refers to the design and implementation challenges that arise when unnecessary complexity is introduced not only into the code but also into the architecture, database design, workflows, deployment pipeline, or technology stack. It often results from quick fixes, suboptimal design choices, or over-engineered solutions that are more complicated than necessary. Organizational accidental complexity is about the structure and coordination of people and teams. It arises from inefficient processes, unclear roles, poor communication, business misalignment, lack of alignment between teams, and so on. It emerges when the structure or the way teams work together becomes too complicated, making it harder to achieve goals and slowing down progress. Compared to technical accidental complexity, organizational accidental complexity is often harder to deal with. We will be talking about this shortly. Now let's walk through a simple example just to illustrate the idea. Don't worry too much about the details. Think about an instant delivery system with thousands of couriers and over 15 different streamlined teams that are developing and maintaining the system. The business team has observed that couriers are reluctant to take long distance deliveries. To incentivize this, they propose the following rule. If a courier makes more than 6 km delivery distance 5 times in a day, they will receive a $50 reward. If they make more than 6 km 10 times or more in a day, they will receive a $100 reward. The first complexity: unclear requirement details. The product manager provides the broad requirement for the reward system but doesn't clarify important aspects such as how the system will act for the canceled deliveries, how the system will act for the returned deliveries. Or as an edge case, imagine a courier who has completed 4 long distance deliveries by 11 p.m. but runs into a technical issue caused by the system just before starting the 5th delivery, preventing them from receiving the $50 reward. How should we handle this situation to ensure the courier isn't unfairly affected? This is the first complexity we've encountered, and we are not at the implementation stage yet. There are some uncertainties regarding the requested task, which will naturally lead to back and forth discussions between the engineering team, product manager, and stakeholders, and a slowdown in the entire process, potentially in the entire sprint. All these will eventually add an organizational accidental complexity into the process. The second complexity, dry violation. Both the courier management and finance teams are responsible for calculating the courier rewards. The courier management team needs to display the reward in real time, while the finance team calculates it for payroll processing. As a result, both teams are implementing the same calculation in their respective contexts. Let's take a moment to address a common misconception about dry violations. Many developers think of them as purely technical issues like duplicating a piece of code. But there's a bigger concern, duplicating a business process, as we see in this example. When dry violations happen on the organizational side, they can be much harder to fix. Back to our example, this cross-functional misalignment inevitably leads to duplication and inefficiencies. And again, we are still not at the implementation stage, and the dry violation in this case adds another organizational accidental complexity into our system. The third complexity, over-engineering this solution. The finance team implements an overly complex solution using excessive class structures, unnecessary abstractions, and design patterns rather than choosing a simpler and cleaner design. This should be clear to most of us. The complexity here lies in the code base, and it leads to increased technical overhead, slower delivery, and a higher risk of bugs. We are now at the implementation stage, and the engineering team just adds a technical accidental complexity into our system. The fourth complexity, tight coupling between systems. Due to high workload, the courier team delegates a calculation that should be handled on the backend to the application side, which causes a tight coupling between these two systems. And tight coupling leads to reduced flexibility, increased maintenance effort, slower delivery, and once again, a higher risk of bugs. Clearly, this is another example of technical accidental complexity occurring in the implementation stage. And the last complexity, business misalignment due to change in business priorities. Shortly after the feature launch, the business team pivots and realizes the need for a more holistic solution. They request a new feature that changes the long-distance incentive into a broader reward system. This is one of the worst scenarios we can face, and will likely lead to frustration, a loss of trust, reluctance to rework, and pressure to adapt quickly. The initial long-distance incentive feature may end up sitting idle in the code, to be removed someday in the future. This time pressure to implement the new feature will likely lead to new suboptimal decisions, adding even more complexity into the system. And once again, we find ourselves dealing with organizational accidental complexity at this stage. So in this example, we've seen how easily these complexities can arise and disrupt our systems. And this is just one feature. Now imagine tens or even hundreds of them piling up over time. Eventually you'd be buried under them, unable to move. There's another crucial point in this example that you may have already noticed. The high cost of organizational accidental complexity. Dealing with it is like untangling a huge knot made of people, processes, and decisions. It's messier than fixing code because it's not just about the software. It's about how teams communicate, who owns what, and how everyone works together. Misalignment slows everything down, causes duplicated work, and creates tension between teams. Even worse, it spreads silently. Small misunderstandings can snowball into major problems. Fixing it requires alignment, trust, and sometimes even changing the way people work together. Along the way, you may encounter hidden resistance to change. That's why organizational accidental complexity often has a deeper impact and a far higher cost than any technical complexity. Preventing accidental complexity, whether it's technical or organizational, requires intentional practices, clear disciplines, and a culture that actively values simplicity and alignment. Organizations that master these approaches can avoid unnecessary mess, speed up delivery, and reduce costly mistakes. So, what are the most important practices and disciplines that help teams and organizations stay on track and prevent accidental complexity from creeping into their systems? Let's take a look. Strong implementation of strategic domain driven design. Break your system into clear, business aligned contexts. This prevents overlapping solutions, reduces handoffs, and stops accidental complexity from creeping in. Strategic domain-driven design ensures that every team focuses on a well-defined part of the business, aligns closely with stakeholders, and makes decisions that serve the overall organizational goals, minimizing inefficiencies and misalignment before they escalate. Agile Scrum practices. Deliver in small increments, validate quickly, and adapt. This helps prevent over-engineering and keeps work aligned with real needs. Remember, Agile isn't just for teams, it's for the entire organization. Without fully embracing the Agile mindset and practices, a company risks a sloppy implementation that creates the illusion of being Agile, while the full benefits are never realized. Empower teams. Give teams autonomy and authority to make decisions. Empower teams spot inefficiencies early, simplify workflows, and resolve organizational misalignments before they escalate. Their ownership of outcomes drives simpler, more efficient solutions, crucial for managing accidental complexity. They are also better suited to putting the post-agile mindset into practice. Organizational discipline. Documentation of decisions. Record architectural and process decisions such as ADRs to avoid repeated debates, inconsistent implementations, knowledge loss, and delays. Standardized workflows. Define consistent processes for code reviews, deployment, testing, and product delivery throughout the organization. Continuous feedback loops. Reflect on what caused delays or issues and adjust practices proactively through retrospectives and postmortems. Strong cross-team coordination. Establish rituals like alignment meetings, cross-team retrospectives, shared documentation, and clear ownership to prevent duplicated works and silos. Simplicity in design. KISS. Favor simple solutions over complex ones that don't add real value. YAGNI. Avoid implementing features or abstractions just in case they might be needed in the future. Continuous refactoring. Continuously improve the code base to remove the application unnecessary abstractions and the code that's no longer in use and don't let them accumulate. Prototyping and experimentation. Test ideas early with small prototypes. This helps catch issues, validate assumptions, and avoid building unnecessary complexity before going all in. More or less, we are all navigating some degree of mess in our systems. Because in reality, it's almost impossible to build a system completely free of accidental complexity. Companies accept it sometimes without realizing it, sometimes deliberately as a trade-off for speed, control, or risk mitigation. However, things get really difficult when an organization lacks awareness of accidental complexity, its costs, and the skills and experience needed to manage it effectively. Thanks for watching. I hope this video gave you a clearer understanding of accidental complexity, its impact on organizations, and the ways to handle it. If you enjoyed it, please hit the like button and subscribe so you won't miss the upcoming videos.